Okay, good morning. Welcome to
MathForKids number 203.
203. So we got a couple more videos about power, so I thought we'd do a really neat problem this morning, and we're kind of constrained to the small whiteboard this morning, which is fine, but you ready?
Yeah.
2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 to the 3 plus 2 to the 9th plus 2 to the 10th. What does this equal? That's what we're going to try to solve today. And now this looks like a pretty complicated problem, right?
Yeah.
So what are some strategies that we've talked about to solve complicated problems?
Make them simpler.
Okay, what's a simpler problem?
Well,
what's a problem that looks kind of like this but is a lot easier?
you could write this backwards.
Right, that worked when we were adding up lists of consecutive integers. So that would be one thing we could try. What's another way to make a problem? What's a problem that's similar to this but a lot easier?
Almost similar but a lot easier.
Yeah, we're going to look for patterns. What's a problem that's similar to this but much, much easier?
Or we could write out what each of them are.
Yeah, we could. That would be the exact same problem, though. We're looking for a problem that's similar but easier.
We could do 2 to the 0 plus 2 to the 1 plus 2 to the plus 2 squared.
Okay, that's good. 2 to the 0 plus 2 to the 1 plus 2 squared is a problem that's similar but a lot easier. Okay? What is this? What's 2 to the 0?
It's 1.
1 plus
2.
2 plus
4.
And what does this equal?
1 plus 2 plus 4 is 7.
Okay, so 7. All right, what's a problem that's a little more complicated than this, but still simpler than the one from before?
2 to the 0 plus 2 to the 1 plus 2 squared plus 2 cubed.
If I add 2 cubed, I'm adding 8, right?
Yeah, so it's 15.
Okay, so so far I have 7, 15. Okay, what do you think I should look at next?
2 to the 0 plus 2 to the 1 plus 2 cubed plus 2 squared plus 2 cubed plus 2 to the 4th.
Okay. What am I adding on when I add on 2 to the 4th?
You're adding 2 to the 4th is 16.
16. I'm adding, well, so it's 15 plus 16.
15 plus 16 is 31.
31, okay. Do you see any pattern yet? 7, 15, 31?
Well, you were adding 8 to 7 to get 15, and then adding 16 to 15 to get 31.
Okay, so 7, 15, 31 look a lot like powers of 2, right? They're very close to powers of 2.
Yeah.
Okay, so let's look at 2 to the 0 plus 2 to the 1 plus 2 squared, which is 7, which is 2 cubed minus 1. 2 to the 0 plus 2 to the 1 plus 2 squared plus 2 cubed is 15, which is
2 to the 4th minus 1.
2 to the 0 plus 2 to the 1 plus 2 squared plus 2 cubed plus 2 to the 4th is 31, which is
2 to the 5th minus 1.
2 to the 5th minus 1. So actually we have a guess as to what, when we add 2 to the 0 plus 2 to the 1 plus 2 squared plus all the way up to 2 to the 10th, we have a guess as to what that's going to be. And what is that guess?
That guess, it's going to be 2 to some power minus 1.
It's going to be 2 to some power minus 1. Can we get a guess on what the power might be? When we add up to 2 squared, what do we get?
We get the 2 cubed minus 1.
When we add up to 2 cubed, we get
2 to the 4th
minus 1. When we add up to 2 to the 4th, we get
2 to the 5th.
When we add up to 2 to the 10th, we think we're going to get probably
2 to the 11th minus 1.
2 to the 11th minus 1. Now, do you remember what 2 to the 10th is?
2 to the 10th is 1024.
Okay, so 2 to the 11th is
2048.
Okay, so we think that 2 to the 0 plus 2 to the 1 plus 2 to all the way up to plus 2 to the 10th is going to be 2047. That's pretty neat, right?
Yeah.
Yeah? So how did now I haven't shown you that it's true yet, but I just want to stop here. We had a complicated problem adding up all these numbers. We made a simpler problem. We could have even made something that was simpler than this, right? We could have just said 2 to the 0 or 2 to the 0 plus 2 to the 1. But we made a simpler problem and looked for patterns, and we found a pattern that gave us a pretty good guess. right?
Yep.
And you know what? That's actually the right answer. So adding up powers of 2 has a neat little pattern to it. Isn't that fun?
Yeah.
All right, good job today, sweetie.